Hello everybody, getting ready to do lesson 3.3 part 2 today for Algebra 1 Math. And on your classwork sheet, you got 22 points. Students have that out ready to go. You'll have 8 points that will go into your notebook or your notebook guide. 3.3 graph using intercepts, part 2. Students, put your name, date, period here on your phone, your iPad, your PC, your Chromebook. Going to page 1 of today's lesson, which is a notebook entry. Example 3, use a graph to find intercepts. So the graph crosses the x-axis at 2, 0. The x-intercept, here's 2, 0 here. The x-intercept is 2. Here's your x-intercept. The graph crosses the y-axis at 0, -1, which is down here. The y-intercept is -1, which is here. Here's your line. Students, so here is a blow up of that. So you have, here's your x-intercept, here's your y-intercept down here. So what do we do with that? Well, let's do a guided now. Find the x-intercept and the y-intercept of this function here, okay, of this graph. You do the same thing down here, students, but guided first. So find the x-intercept and the y-intercept. Y equals -14x plus 7. So here's your x-intercept. When y equals 0 equals -14x plus 7, we're going to solve for x. So we move our subtract 7 from both sides, and then we divide through by -14, and we get 1/2 equals x. So there's our x-intercept right there. We make y equal, then we solve for x. So, and then our y-intercept is when we make x equals 0. So we solve for y now. We got y equals 7. Here's our y-intercept. So here's how it looks like on your computer. Here's your x-intercept here. When y equals 0, x equals 0.5. Okay, so that would be your y-intercept. Let's go into a key concept here, relating intercepts, points, and graphs. So intercepts and points. Here's your y-intercept, here's your x-intercept. The x-intercept of a graph is a down here. Excuse me. So when y equals 0, you find your x-intercept. And then when x equals 0, you find your y-intercept. The graph crosses the x-axis at a0. And then your y-intercept of a graph is b up here. 0b or a0. a0, 0b. And again, for your y-intercept, the graph crosses the y-axis at 0b right there. So that's kind of like the strategy for finding your intercepts, is making x or y 0 and then solving for the other. So let's try one then. Solve a multi-step problem here. Well, you are helping to plan an awards banquet for your school, and you need to rent tables to seat 180 people. Tables come in 2 sizes. Small tables seat 4 people, and large tables seat 6 people. This situation can be modeled by the equation 4x plus 6y equals 180. So where x is the number of small tables and y is the number of large tables. So bullet point 1, find the intercepts of the graph of the equation. So 4x plus 6y equals 180. So find the intercepts of the graph. Okay, so we're going to make when y equals 0, we're going to find our x intercept here. So x will equal 45 in this situation. So there's your x-intercept. And then to find our y-intercept, we're going to make x equals 0. So we have 6y equals 180. So y will equal 30. So here's our y-intercept. And then here's our x-intercept. And so give 4 possibilities for the number of each size table you could rent, and then graph the equation. We have our intercepts. We can draw a line through those 2 intercepts, right? Graph the equation. The x-intercept is 45, so plot the point 45, 0. The y-intercept is 30, so here we go. Here's our graph. So for 45, 0, here's our x-intercept out here. And guess what? There's our y-intercept up there. So plot the point 0, 30. So when x equals 0, y equals 30. Here is your line. Here are your possibilities of x and y. So since x and y both represent numbers of tables, neither x nor y can be negative, so we're in quadrant 1. So instead of drawing a line, draw the part of the line that is in quadrant 1, which is what this is. We got our quadrant 1 line drawn. And then find the number of tables for this problem. Only whole number values of x and y make sense. So here's our possibilities then. 0, 30, 15, 20, 30, 10, and then 45, 0. Those are our possibilities. So 4 possible combinations of tables that will seat 180, and here they are. So it's pretty cool finding out your possible combinations. So 0 small, 30 large. So 0 small, 30 large, 15 small, and then 20 large, and then 30 small, 10 large, and then 45 small and 0 large. So that would be the way that you could discover what kinds of tables you would need to seat the same amount of people. Let's go into our guided here. In example 4, suppose the small tables cost $9 to rent and the large tables cost $14. Of the 4 possible combinations of tables given in the example, which rental is the least expensive? Explain. So now we got a cost function that we have to find. So going into this, what if in example 4, suppose the small tables cost $9 to rent and large tables cost $14. Of the 4 possible combinations of tables given in the example, which rental is the least expensive? Explain. So first of all, we found our intercepts. Our x-intercept was at 45. And then our y-intercept was at 30. So we know those were maxing a certain type of table. So here again is the graph. Find a number of tables. Here they are. So we have 0, 30, 15, 20, 30, 10, and 45, 0. So now to find the most expensive combination there. At 0, 30, we plug in our amounts here. And we have 0 tables at $9 and then 30 tables at $14. So we have $420. That's one cost. And then at 1520, you got 9 times 15 plus 20 times 14. That comes out to $415. Okay, so we got 2 combinations there. Then 3010, 30 times 9 plus 10 times 14, that'd be $410. And then the 45-0 combination would be 45 times 9 plus 0 times 14. And that comes out to $405. So there it is. There's our solution. It is the least expensive to rent 45 small tables at $9 each and 0 large tables at $14 each. This combination cost a total of $405, which is less than the other combinations. And that's your lesson for today. Anime PowerPoint Math video at AOL.com for questions or course materials. Thank you very much.